All right, so today we're going to take a look at using the summation symbol to work with our series and sequences. Now, this first part's not really necessary, but I like doing it just so the variables kind of match up better. I'm going to go to mode, and I'm going to change it from function mode down here over to sequence mode right here. The only thing this is going to change for our problem is change the variable from an x to an n, so it kind of matches better with what we're doing for each of our questions. So I'm going to go ahead and do that, and I'm going to quit out of there. So if we want to do the summation of something, now obviously we can do it by hand, but like in this example here, going from 1 to 17, that's obviously very tedious. So what we'll do is we're going to go to math, and then we're going to scroll down until we get to summation, which is option 0. So if you remember that, you can just type in 0 and automatically do that for you. Here, I'll show that. So we just do math, type in 0, there's our summation. So we're going to use our variable. This is our main variable button, and you can see it's an n because I changed it to sequence mode. So it's going to be n equals 1, and the top is going to be a 17. And all we're doing is just filling in the exact way it looks here. Now it's going to be 4n squared. So 4n squared plus 1, and we hit enter. And that would be the summation of that particular expression, 4n squared plus 1 from 1 to 17, which obviously you could check that if we did 4 times 1 squared plus 1, 4 times 2 squared plus 1, and so on. Obviously very tedious, but that's exactly what this calculator is doing for us, much quicker. So that's a simple thing. I'm going to show you 2 other examples that'll be coming in handy with these infinite sequences. You'll see with the pre-calc videos in 11.6 for the exponential and trig. I'll do one trig example, not both the trig examples. And those will be a little more interesting to type into the expression. All right, so we're taking a look at right here our infinite, well, not really an infinite because we're going from 0 to 4, but our summation that's based off the approximation of e to the 1.4 power. That's what this formula is coming from, a partial sum with that. So those of you coming from the 11.6 video for the pre-calculus videos, this is what we're looking at here. So again, we go into our math, do our summation, which is option 0, n equals 0 to 4 is the numerator. On the insides of fractions, we're going to go ahead and do our alpha y equals. The numerator is our 1.4, which would be the exponent raised to the power of n. And our bottom is just simply n factorial. So if you remember from our permutation combination video, we then go to our math, we scroll over to probability, and we select the factorial symbol for that. So we get 3.9974. Which if you compare that to the exact value of e to the 1.4, you can see it's pretty darn close. In fact, if we were to do the same summation, but instead of doing it into 4, let's do it to a bigger number. Let's not even go too crazy. Let's say we're doing this to the 10 rather than a 4. You can see right there, it's practically the same thing as e to the 1.4. And the bigger we get, the better the approximation would become. Let's say, again, instead of a 10, let's just make it 100. It's going to take a little bit longer. Nope, overflow. Didn't like that. Maybe we don't want to do 100. Anyway, so the whole idea is just going to get a little more accurate as we go further and further with that. Though in our class, we're only going to really do 5 partial sums for that. But that's where this formula comes in. That's how you want to type it in. So next we'll do one of the trig ones. We'll do the sine one, not the cosine one, but it's the same exact process. All right, so here we have our sine expression for summation. So we're going to go ahead and type that in. So this is finding the approximation for sine of pi over 5, which again we'll compare to the exact value once we're done with this. So again, we're going into our math, option 0 for our summation, n equals 0 on the bottom, 4 up top, alpha y equals for our fraction. Now we got a bunch of stuff going on. We have -1 to the n power first. We then have pi over 5, which I'll just do pi divided by 5. I'm not going to need the fraction symbol there again. Raised to the 2n plus 1 power. And on the bottom, we want 2n plus 1 factorial, so we got to do that in parentheses, 2n plus 1. And then our math, scroll to probability for our factorial symbol on the bottom. We're getting 0.58778, all that kind of stuff, which we compare that to the exact value of sine of pi over 5. Wow, that is actually right there. That's actually kind of impressive. I was expecting to be off a little bit because, again, it's only 5 partial sums there, but it's practically the exact value that we're getting. And that's what the calculator is doing. The built-in form for these calculators for doing sine or cosine when we have the cosine form, or that e that we did in the previous example, it's doing this infinite summation. That's where these things are coming from. All right, so those are just some examples of using the sigma notation, at least relevant to our class. You can use this really for anything. Whatever you're trying to sum, just type it in the same kind of way you're seeing there. All right, as always, I appreciate you guys watching, and I'll see you next time.